Quantum leap: how Alain Aspect's experiments challenge retrocausality. In Alain Aspect's experimental setup, altering the photon's path via mirrors after the entangled photon has departed demonstrates that it cannot be predetermined with variables before departure. Does this setup also refute the concept of retrocausality? Alain Aspect's groundbreaking experiments in the 1980s provided critical empirical support for the non-locality of quantum mechanics by testing Bell's inequalities. These experiments showed that measurements on entangled particles exhibit correlations that cannot be explained by any local hidden variable theory. Specifically, Aspect setup allowed for real-time changes in measurement configurations after the entangled photons had departed their source. Key elements of Aspect's experiment. Changing measurement settings. Aspect's experiments involved switching the polarization measurement settings of entangled photons while they were in flight, using rapid electronic switching. This ensured that any potential hidden variables encoding predetermined outcomes could not account for the observed correlations. The photons while together could have agreed on their behaviors before departure, once separated on their respective paths, but Aspect's clever approach was to have them act while they were already separated on their paths. Yes, that's correct. In Alain Aspect's experiment, the key was to change the measurement settings, via mirrors, while the entangled photons were in flight, ensuring that the photons couldn't possibly conspire beforehand about their behaviors. This setup effectively closed the locality loophole, meaning that any communication between the photons would have to travel faster than the speed of light, which is forbidden by the theory of relativity. By doing this, Aspect was able to demonstrate that the measurement outcomes were correlated in a way that couldn't be explained by local hidden variables, thus supporting the phenomenon of quantum entanglement. Violation of Bell's inequalities. The experimental results consistently violated Bell's inequalities, confirming quantum mechanics predictions and ruling out local realism. Does this dismiss retrocausality? Aspect's experiments were designed to address the possibility of predetermined hidden variables but did not explicitly aim to test retrocausality. However, they do strongly constrain how retrocausality could operate. Arguments against retrocausality. The results suggest that the entangled particles' correlations are determined in a way that is independent of local preconditions or changes made after the photons have departed. Retrocausality would require a mechanism for future measurement settings to influence the photon's earlier behavior. No evidence from Aspect setup supports such influences. Instead, the results align with non-local correlations as described by quantum mechanics. Interpreting quantum correlations. Quantum contextuality and non-locality provide frameworks for understanding these results without invoking retrocausality. The entangled state is not determined by past variables but exists as a non-local, holistic quantum state that responds to measurement in a way consistent with the entire experimental configuration. Recent insights. Subsequent experiments and theoretical analyses, e.g., by Anton Zeilinger and others, have reinforced these findings, showing that quantum correlations are not constrained by classical causality but are instead manifestations of the intrinsic non-locality of quantum states. These studies further diminish the necessity or plausibility of retrocausal interpretations. Conclusion. While Alain Aspect's experiments do not explicitly dismiss retrocausality, their results align more naturally with interpretations of quantum mechanics that involve non-locality and contextuality, rather than retroactive causation. The consistency of these findings across decades of experiments suggests that retrocausality is not required to explain quantum phenomena. Instead, the peculiarities of quantum mechanics can be understood within its existing non-classical framework.